Okay. Good morning. Today we are going to discuss memory segmentation. Now, first question that should come into your mind is what is memory segmentation? What is it and why? So, memory segmentation is this is my memory. Okay. One more thing that you need to keep in mind is your microprocessor is different and your memory is different unit. Both are different. Your microprocessor is accessing your memory. So memory is a different unit, right? And when we are talking about memory in context of 8086, it is RAM. Fine. So first question is what is segmentation? So instead of suppose this is my memory, I have divided my memory into different parts. This is called segmentation. So in 8086, we are dividing our memory into different number of segments, and that's why it is called memory segmentation. So the second question that should come to your mind is why memory segmentation is needed. What's the problem with a single short memory? Is it clear? Hello.
Yes. Yes, sir.
Okay, so what is it clear now? What we are discussing? We are discussing memory segmentation. What is memory segmentation? We are dividing memory into different number of segments. The question is why we need to do this? What is the problem so that we need to do this? So this is the problem that we need to answer. Yes?
Yes, sir.
Okay, now your memory will contain three things. It can contain programs, it can contain data, or it can contain stack also. Now, what is program? The program that a user is writing is a program that is available in your memory. Normally, this program is written in sequence. So this is the flow of your program. It will be in sequence only. Okay. Now, data is any data that you are using for your program or for any other purpose. So data is stored in memory in random form. So it can get stored upward also, it can get stored downward also. So that is your data. Understand? And the third thing is stack. For background operations, stack is available in memory, and you know the concept of stack. If this is my stack, I can push anything on top of the stack. So it will increase upwards. So actually, it will go like this. Get it? Every time I need to decrease my address so that stack will work. Every time I need to decrease my address and it will go up. So my program is stored sequentially, top to bottom. My data is stored randomly anywhere in the memory, while my stack is growing upwards. This is clear? Hello? Are you there?
Yes, sir.
Please respond.
Yes, sir.
So thing is now data is stored very randomly. Now when you are writing program, you don't know where you are writing your code. So it is possible that this is my stack region. I have already stored something over here, 55. But when I am writing some my code, I am overwriting this 55 to 80. So in this case, my data will get overwritten because as a programmer, you can't keep track of everything, where my stack is, where my code is. So it is possible that because of a longer program, it gets overwritten. So your data may get changed or your stack may get changed. That is possible. Yes? Yes? Hello?
Yes, sir.
Yeah, so problem is if I am having a full memory which contains stack also, which contain data also, and which contain program also. So many times it is possible that user by mistake overwrite some of the data. So overwriting is one of the problem that we need to take care. That's why segmentation is needed. This is one of the reason overwriting of data. And because of that, to resolve this issue, we are using segmentation. Now, how segmentation resolve this issue, that we'll study in this session. But this is the problem. Understand? Clear? Am I making myself clear?
Yes, sir.
So first problem is overwriting of data because of user unawareness about memory parts. That's why we need to do segmentation. Okay, now as far as 8086 is concerned, our memory is of 1 MB. If my memory is of 1 MB, okay, with suppose now go little bit backside. Suppose I'm having 1 bit. How many address I can give? 2 address, 0 and 1. If I am having 2 bits, 00011011, I am having 4 combinations, so 4 memory location I can address. If I am having 3 bits, 0000012111, total 8 different combinations possible. I can give address to 8 different locations. So if I want to give address to one memory of 1 MB of memory, how many address lines are needed? How many bits are needed? If I want to give address to two locations, 1 bit is sufficient. Address is 0, 1. If I want to give address to 4 locations, then 2 bit is enough. 0, 0, 0, 1, 1, 0, 1, 1. If I want to give address to 8 different locations, 3 bit is enough. 0, 0, 0 to 1, 1, 1. Same way, if I want to give address to 1 MB of locations, how many bits are needed? Can someone tell me? Hello? Are you there?
Yes.
Okay. Thing is, we require 20 bit. 2 raised to 20 is equal to 1 MB. If you remember, this is nothing but a power of 2. So if I am having a 20 bits address available, I can give maximum of 1 MB of different location addressing. Get it? Hello? Hello?
Yes, sir.
Yes, sir.
Yes. So what? Please speak. Don't sleep here. If you are not interested, go sleep at your place and watch this video later on. No issue. If you are in a meet, be interactive. That is required. Yes?
Yes, sir.
હા આ યસ કહેતા આટલી બધી વાર લાગવી નહીં જોઈએ અને બધાએ બોલવું જોઈએ. Those who are just here for the sake of attendance, leave the meeting, enjoy outside, watch this video later on. I will drop it once the lecture gets over. Fine? I don't want to
Yes,
make
sir.
this video longer, so better start concentrating here. So what that mean is, in 8086 we are having 1 MB of memory. Now we can give unique address to each and every location. It is compulsory. Then only we can put something in our memory. So if I want to address 1 MB of memory, I require 20 bit number. So if I require 20 bit number, my address bus must be of 20 bit. Done? So in 8086, you are having 1 MB of memory, you are having 20 bit of address bus. Fine?
Yes, sir.
If I am having a 20 bit of address bus, the minimum number that I can address is 00000H. This is hex number. 1 digit represents 4 binary bit. So 5 digit means 20 bit. Is it fine?
Yes, sir.
Same way, the maximum number that I can allocate is F, 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 F. This is my 20 bit number. Why this is 20 bit number? 1 hex digit represent 4 binary bit. These are 5 digits. So 5 4s are 20. So this is my 20 bit number. So minimum number in my 8086 is 00000H. The maximum number of memory location is FFF, Fine?
Yes, sir.
Yes, sir.
Now, till now, what we have covered, there is a segmentation in 8086. Okay. What is the problem? Why we need segmentation? Because of overwriting issue. Because user is not aware about where he or she is writing. That's why we need to do segmentation. Now, if you do segmentation, you first need to understand what's there in 8086. So in 8086, 1 MB of memory is available. To access that memory, we are having 20 bit address was available, and the minimum address and maximum address is this. Fine? This much thing we have covered. Is it okay?
Yes, sir.
Okay, now next. Who creates segments? User will create segment. Programmer will create segment. So in this memory, my code segment will start from here. This thing is decided by programmer. My data segment will start from here. This thing is decided by programmer. So programmer will decide where I want to start my segment. Okay? It is in the hand of programmer. So in future, when you do assembly language programming, you can decide yourself that where your code segments should start or where your data segments should start. So who can create segments? Who can create segments?
Programmer.
Programmer, or we people create the segment. But who will manage segment? Microprocessor. Once we create the segment, it is microprocessor headache that it need to take care that data should not get overwritten and my code should be reset in my code segment only. My data should reset in data segment only, like that. Okay, so segments are created by programmer, but it is managed by.
Microprocessor.
Very good. So this much thing is clear.
Yes, sir.
Okay, next. Now, what are the advantage of doing the segmentation? First, we can prevent overwriting, right? As we have discussed. How? That will study soon, but this will prevent overwriting. So that is the first advantage. What is the second advantage? This concept has given the birth of file and folder system that you are using right now. Right now, you don't know any physical location of your memory. Do you know any location? 100111? No. What you are knowing? I am having a desktop folder which contain xyz.doc file. Yes?
Yes, sir.
Yes. This folder is your segment, and this file is also one of the segment. Like this way, it will treat it. Every file is a segment. Done? If it is a movie, it is a data segment. If it is a application like WhatsApp or anything, it is a code segment. Done? So in a way, because of this concept, currently we are using concept of files and folder. It comes from this concept only of segmentation. So that's why it is very important. Clear?
Yes, sir.
Hello. A same example is written over here. Each application, WhatsApp,
Yes,
FB
sir.
is your good. Each application is your code segment, right? And so nowadays in our memory, there are so many segments available, right? Every program is one segment, and every movie that you are storing or every song you are storing is one segment. Yes?
Yes, sir.
So there are so many segments available in our current processor. Okay. And the one that you are using, which is coming into the RAM, is called active segment. Okay. એટલે કરન્ટલી હું સપોઝ જિંદગી ના મિલેગી દોબારા જોતો હોઉં તો that is my current active data segment that I am using. Yes?
Yes, sir.
Yes, sir.
So this
Yes,
much
sir.
clear? Hello, this is clear?
Yes, sir.
Yes, sir.
Okay, now let's come to our 8086. Now in 8086, your full memory is divided into 4 segments: code segment, stack segment, data segment, and extra segment. In code segment, whatever program that you are writing is stored into code segment. Your stack, which is used inside your programs, are stored in stack segment. Data segment, where your data is residing. And extra segment is when your program is bigger or if you need to store more data, this segment is used. Done? Hello?
Yes, sir.
Yes, sir.
Okay, this full memory is of 1 MB as we have discussed. In each location, we can store 8 bit or is equal to 1 byte. So each memory location in 8086 can store 1 byte of data or 8 bit of data. Clear? Hello, if this is my memory, this is my different location. તો આમાં કેટલા બીટનો ડેટા સ્ટોર થશે? 55 in hex 8 bit, 11 hex 18 8 bit. Get it? So we can store 8 bit data in one location. Fine.
Yes, sir.
My minimum address will be 00000h. Maximum address will be ffffh. Okay. This is clear? Hello.
Yes, sir.
Now there is one problem in 8086. The problem is our physical address, the actual address is called physical address, right? A memory, આ જે address છે FFFFH and 0000H, this is called physical address. What it called?
Physical address.
Physical address, actual address. Now there is a problem with this. What is the problem? Our address is of 20 bit. Yes.
Yes.
Hello. But this 20-bit address is not byte compatible. What do you mean by byte compatible? You are having 8-bit data, 8-bit data, 8-bit data. So if I want to store this 20-bit data, I need to use this full block. And if I use this full block, every time I am losing my this 4-bit. Yes?
Yes.
Yes, sir.
So every time you are wasting your 4-bit if you are using our simple strategy of 888 bit. So 20 bit is not compatible with byte format, and that's the issue. Our address bus is of 20 bit while our data bus and all our processing will be done in 16 bit. Understand? Yes. Yesterday we have seen our microprocessor is 16-bit microprocessor. Why it is 16-bit microprocessor? Our data bus size is 16-bit, while all the processing done in your microprocessor is also of 16-bit. So our processor is of 16-bit, while our address bus is Address bus is what size?
20 bit.
20 bit. Now this is the problem. One is because of this 20 bit we are wasting memory. તો તમને કદાચ ક્વેશ્ચન થવો જોઈએ why they have not used 16 bit address bus, because એ લોકોને મેમરી વધારે જોઈતી હતી. So they have chosen 1 MB of memory. Using 16 bit address bus, how much memory I can access? 2 raised to 16 is equal to 2 raised to 6 into 2 raised to 10. 2 raised to 6 is 64 into k. So 64k only you can use if you are having 16 bit bus. Yes? This
Yes,
we have
sir.
first lecture. So they want more memory, so they have chosen 1 MB of memory. Now for 1 MB of memory, they require 20 bit address bus. But problem with this is not byte compatible. Plus every time we are losing 4 bit if we use this address. Fine? Yes.
Yes, sir.
So moral of the story is 20 bit address bus is wasting our memory, and we want to work with 16 bit of data. Okay, and all our registers are also of 16 bit only. So in register also we can store only 16 bit data, we can't store 20 bit data. Yes. Yes.
Yes, sir.
Yes,
Okay.
sir.
Okay, so this is the problem. Now to solve this problem, they have come with this. So this is the solution. Instead of using physical address, we are using virtual address. Okay? And our virtual address is of only 16 bit. So now using this 16 bit address, we can access any of our memory location, and still we can do all the operations that we are doing currently. Understand? Tamara, okay, let's take the example of your current microprocessor. Your current microprocessor is having 14 bit, suppose, address bus. That means the address that you are accessing is of 64 bit. Now you don't remember physically what that each address is like look like. What is the number? F, A, B, C, A, H. We can't remember all these numbers. So what we are doing, instead of using this physical address in our program, what we are using? X, AB, or file name. Yes? Hello?
Yes, sir.
And these file names are mapped to this physical address. So these file names are virtual address for us. Same way, to work with 8086, we can't use 20 bit data because not a single register that we are having is of 20 bit. All registers that we are having is 16 bit. So we can only deal with 16 bit. So what we have done, instead of accessing 20 bit of data or storing 20 bit of data, which can give us a loss of 4 bit every time, what we'll do is, instead of using physical address, we are using, what we are using?
Virtual address.
Virtual address. Good. But your microprocessor at the end require 20 bit to access your memory. Yes? Because actual address is of 20 bit. So we need to convert our 16 bit address to 20 bit address. Yes?
Yes, sir.
Okay. Just for the sake of revision, let me tell you again. Our memory is divided into 4 parts: code segment, stack segment, data segment, extra segment. Our memory is of 1 MB. Our address bus is of 20 bit. Okay, so each physical address is of 20 bit address. Okay, એટલે મારે મેમરીમાં કંઈ પણ સ્ટોર કરવું હોય કે કંઈ પણ વાંચવું હોય તો મારે મેમરીને 20 બીટનો એડ્રેસ આપવો પડે. Yes.
Yes, sir.
Yes, sir.
But your microprocessor, this 20 bit is not byte compatible. So if you use that format and if you use some 20 bit register, every time your 4 bit will get wasted. So that is not the solution. So what is the solution? You can use your 16 bit registers only. But in that case, you need to convert your 20 bit address into 16 bit address. Then only you can work. Yes? Yes. This 20 bit address that is actual address is called physical address, while the one that you are using is called virtual address. So 16 bit address is virtual address. So now, because the limitation of our processor and because we don't want to waste this memory, we are using virtual address of 16 bit. Done? Hello? Yes?
Yes, sir.
Yes, sir.
Okay. Now, Now, if you are using 16-bit virtual address, but your processor require 20-bit address. So every time in the background, when you give the 16-bit address, your processor need to convert that address into 20-bit. Yes, yes.
Yes, sir.
Okay, so how it do? This is the equation by using which your processor will convert your 20-bit address into, sorry, 16-bit address into 20-bit address. So your virtual address will look like this. Your virtual address is equal to segment address colon offset address. Segment address colon offset address. Your segment address is of 16-bit. Your offset address is of also 16-bit or 8-bit. Okay. Now what we'll do? Currently, just keep this in mind. You are using your virtual address in the form of segment address colon offset address. And if you want to create 20-bit from this, so suppose my segment address is 1234 and my offset address is 1111. Now, first understand what is segment address and what is offset address. So, suppose my code segment starts from this location. Then this is called my segment address. This is my starting point of port segment. And અહીંયાથી મારે ચોથી location access કરવી છે. I want to access my fourth location from the top. Then this is 4 is my offset address. Understand? Yes. Hello.
Yes, sir.
Another example is suppose મારી પાસે એક textbook છે. If I am having one textbook available with me, okay, મારે એમાં પાંચમા ચેપ્ટરનું ચોથું પાનું એક્સેસ કરવું છે તો ફિફ્થ ચેપ્ટર ઇઝ માય સેગમેન્ટ એડ્રેસ 4 is my offset address. Offset is nothing but from the starting point how much you want to go in, that is your offset. So મારે પાંચમા ચેપ્ટરનું ચોથું પાનું વાંચવું છે તો 5 is my segment address, 4 is my offset address. From the data segment, suppose I want to access 100th location, so this is the starting point of data segment, then this is called segment address. અને અહીંયાથી મારે 100મી લોકેશન પર જવું છે 100, so this 100 is my offset address. Understand?
Yes, sir.
Okay, so how you give your virtual address? Segment address colon offset address. So 1 2 3 4 is the starting point of my segment and 1 1 1 1 is the offset which I want to access. Now this is 16-bit address, this is again 16-bit address, but I want to convert it into 20-bit. Yes?
Yes.
Okay, so what is the equation? Segment address into 10 plus offset address. This will give me 20-bit address. This is called physical address. So suppose 1 2 3 4 is my segment address. So the starting point will be 1 2 3 4 into 10. So 0. Give me a minute. Pranav sir. So this is my number plus I want to go to 1 1 1 1. So 1 3 4 5 1. This is the number of location on which I want to store my data or access my data. This is actually my physical address. Understand? This is the process done by your microprocessor inside. Yes?
Yes, sir.
Yes, sir.
Is it clear? Okay, one more example of physical address and virtual address is suppose your enrollment number is your physical address, your actual number, right? But I don't remember your enrollment number fully. 2020 061 0011 0089. I can't remember that. Yes?
Yes, sir.
So we have created virtual address. What is the virtual address? You are third semester student. In third semester, give me 89 number. So third semester is my segment address, 89 is my offset. It is as simple as that. Still it will give me the same number, but if I call that guy or girl, her full enrollment number is different. That is actually the physical address. Samajh padi?
Yes,
Yeah.
sir.
So now instead of calling your enrollment number, full enrollment number every time, what I need to call every time? Only offset number, because I know you are from third sem. So segment address, once it is getting fixed, once your segment is fixed, address is fixed, you just need to take care about offset. If I want to take attendance every time, I don't need to give you segment address. Third semester 81, third semester 82, I don't need to call it because third semester is already known to me. Segment address is already decided. Now what I need to change? Only offset. So I just, if I want to take attendance, now what I will call? Number one, number two, number three, and I can get the data. Yes?
Yes, sir.
Same thing happens over here. So if in this memory, if I want to fetch some data, data segment is fixed. Now it is done. So now if I want to access anything, go to 100 location, go to 101 location, go to 103 location. So I just need to change my offset. So I just need to work with 16-bit data and still I can operate on my physical address, that is 20-bit. And it will give me a fast result. Complete?
Yes, sir.
Okay. Now, if 8086 segmentation compulsory, in 8086 segmentation is compulsory? Yes, it is compulsory. Why it is compulsory? Because as I said, if you don't maintain it, it will get overwritten. Yes? So you need to do this. Hello?
Yes, sir.
Okay, just for the sake of revision, physical address is of 20-bit, segment address is of 16-bit, offset address is of 16-bit. Okay, physical address कसे use થાય by us? No, we are never use physical address. We never use this 20-bit data. What we use? We always use virtual address. Yes? Hello?
Yes, sir.
In virtual
Yes,
address,
sir.
also, it is segment address colon offset address. Segment address is used how many times? Only once when we initialize. Then we only use what?
Offset
Offset
address.
address. Done?
Yes, sir.
Done?
Yes, sir.
Yes, sir.
It is difficult to understand all these things in a single shot. So let's take some examples. Suppose I am having a जग्या भी नहीं बोलो. Let's take the example of 1248. This is my segment address and I want to go to location 0005. What will be my physical address? Can someone tell me? First, my segment address is 1248. My offset address is 0005. What will be my physical address? 20-bit address. 1248 multiply by 00005. 12485. This is my physical address. Yes? Yes?
Yes, sir.
These numbers are in hex. That's why I take the first lecture of hex. And this is my 20-bit number because each hex digit represent 4 binary bit. These are 5 digits, 20 bit. This address is of 20 bit. Suppose my segment address is 1111 and I want my offset address is 1234. What is my physical address? Fast. 11110 1234. 12344. This is the physical address. Yes?
Yes, sir.
Yes.
Yes, sir.
Okay, actually I was planning to complete full segmentation part today, but I don't think it is advisable to go with this flow because तुमने लोगों ने पढ़से नहीं. So we'll stop over here, okay? And we'll cover this thing in the next lecture. That would be okay?
Yes, sir.
Okay, let's just revise this stuff. First, why segmentation is needed? Can someone answer me? First question, why segmentation is needed?
Prevent from override.
Yes, to resolve overriding issue, because if you don't do segmentation, there are chances that your data will get overwritten, right? Second, in 8086, how many segments are there? Huh? Jaldi, how many segments are there?
4.
Yes, there are 4 segments: code segment, stack segment, data segment, and extra segment. Okay. What is the size of memory?
1 MB.
1 MB. How many address bus? What is the size of address bus to access this 1 MB of memory?
20 bit.
20 bit. Very good. Oh, साहेब, बंद कर दे तो પછી વાત करो. Okay. Fifth. Okay. Now, physical address is of how many bit?
20.
Very good.
20.
Virtual address is of how many bit?
16.
16.
Good. How to represent virtual address?
Segment plus offset.
Segment plus offset.
Segment colon offset. Okay, very good. And how to convert this segment colon offset into physical address?
Segment into 10 plus offset.
Very good. It will give me 20-bit address. Perfect. This is clear?
સર
Ah.
Yes, sir.
તમારા જે લાસ્ટ પોઈન્ટ છે એમાં 5 થી વધારે બીટ થઈ જાય તો એટલે તમે 5 નો નંબર બનાવો તે 6 થઈ જાય તો
Possible જ નહીં. કોઈ સ્કોપ જ નહીં કે 6 પર જાય. Your segment, your minimum segment address in 16-bit will be this. What is the maximum number segment address? This. Yes?
યસ સર
What is the maximum offset is possible in 16-bit? F, 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 F. Yes?
યસ સર
So if I convert this into 5-bit address, F, 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 0 plus F, 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 F. Yes? But this kind of segment is never possible because it is already occupied. That will study in future. So your maximum segment that you can assign is also having limitation. Get it? So you never get the address above 5 F, 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 H. That is never possible. Done?
ઓકે સર
One more thing that will study tomorrow. Actually, what is the maximum size of segment? What is the starting point, ending point? That will study. But you will never get a point where your physical address will be more than this. Never. Done?
યસ
Okay.
સર
સર
Yes, sir.
સર
Yes. Yes.
સર અગર એવું કેસ આવે તો ઈ ઓવરફ્લો થઈ જાય ને એડ્રેસ
આવે જ નહીં. That is not possible in 8086.
એટલે FFFF +1 કરવા જાય તો પછી 000 થઈ જાય કે એવું કંઈક
હા એટલે એવું આવે જ નહીં બી તો otherwise it will give you the throw the error because that kind of facility was not available in 8086. So what happens?
સર
See, you are having 4 segments, okay? And that segments will not get overwritten any point of time. Okay, the size of these segments are not even full of length. જેટલી જોઈએ એટલી નથી નકર 1 MB કરતા ઓછી જ છે. The total of this 4 segment is less than 1 MB and because of this you never get this case. So your memory will never get overflowed. Okay, and you will never get the address, physical address, which is more than this number. Fine? Okay?
ઓકે સર
Done? All of you, clear?
Yes, sir.
Chalo. Actually, I want to cover much, but I don't think it is advisable. So we'll cover these things tomorrow or day after tomorrow. Fine? Chalo. Thank you. Let me stop recording, write down your numbers and you can leave. Go through this video again before you come for the